This is how to determine the specific heat of one metal through mixing of two metal pairs. What is the specific heat of cadmium if a mixture of 100 grams of cadmium at 320 degrees Celsius and 150 grams of lead at 400 degrees Celsius reach thermal equilibrium at a temperature of 357 degrees Celsius? Okay, the important thing to realize is that the heat that the cadmium gains is equal to the opposite sign of the heat that the lead loses. I say the cadmium gains heat because it goes from 320 to 357. The lead loses because it goes from 400 to 357. The formula for these is the mass times the specific heat times the change in temperature. So, on the left side, we're going to have the mass of cadmium, the specific heat of cadmium, which we're solving for, and the final temperature minus the initial temperature. Here, we will have the mass of the lead times the specific heat of the lead, and the final temperature minus the initial temperature. Let me work on the lead side first, since we have all the materials. It is minus 150 grams. I am given the specific heat of 0.13 joules per gram degrees Celsius, and we initially start out the lead at 357 degrees Celsius, and it ends at 400 degrees Celsius. So I can multiply my items out on this column, and it turns out to be 838.5 joules. Now let me work on the other side. I have 100 grams of cadmium. The specific heat of the cadmium is what I'm trying to solve for. The final temperature is 357 and the initial temperature is 320. I can multiply this out and I wind up with let me move it down to this line, 3,700 degrees Celsius times grams, if I pay attention to my units, times the specific heat of cadmium. So now it's just a matter of taking my 3,700 over to the other side. So I will take 838.5 divided by 3,700, and I wind up with 0.2266, which, considering the number of sig figs, my temperature difference was really only 2 sig figs, and also my specific heat of lead. So it's appropriate to report this to 2 sig figs, 0.23, and notice my units are going to be joules on top, and then grams degrees Celsius, which is a perfectly good unit for a specific heat.